Number one, first thing they tell me is that segment AB, this one right here, and segment CD, this one right here, are perpendicular. So I'm going to add that mark to my picture. So how big is AEC, this angle right here? If it's a right angle, how many degrees would it be? 90 degrees. How big would AED be? Also 90 degrees. What about DEB? 90 degrees. CEB? All of those are 90 degrees. Right. Angle CEF, that's this one right here that I went over in purple. And angle FEB, that's this one that I went over in blue. When I put those two together, when I add those two angles together, what does it add up to? 90 degrees. And then part C, we get an opportunity to practice writing an equation from words. What do we know about these two angles right here that we just said in part B? They make 90 degrees when I put them together. Well, angle CEF, this one right here, is, if I'm writing an equation, I'm going to start with this first piece. Measure of angle CEF. When I see the word is, what symbol do I replace that with? Equal sign. CEF is 10 more than. If it says 10 more, what operation are we doing? I have 10 more dollars than you and you have $15. Addition. So we're going to plus 10 onto something. So I'm going to put a plus 10 at the back because I need that thing first, and then I'm going to plus 10 on top of it. What comes after that? 3 times. What operation is happening when we see times? Multiplication. We are multiplying by whatever comes after the word times. So I'm going to do 3 times, and then they have the measure of angle FEB. So M angle FEB. Close my parentheses. We're going to use the substitution property next. All of this right here, that is the same size as CEF. So I'm going to come up here to this equation that we wrote in B, and I'm going to let all of that take the place of CEF. So I would have 3 times the measure of angle FEB plus 10. All of that right there is taking the place of this little bit right here. And then I still have to finish the rest of that equation. So I need my plus sign, measure of angle FEB. I need my equal sign, and it's equal to what? 90 degrees. That's a lot. If I have 3 of these, and then I have another one over here, how many do I have of those all together? 4. So I have 4 times the measure of angle FEB plus 10, that comes down, equals 90. What's my next step going to be as I solve this? Subtract 10 from both sides. So I'm going to minus 10 from both sides. And I'm going to have to bring my work down here because I ran out of room. So that's going to cancel. I have 4 times the measure of angle FEB equals, what's 90 minus 10? 80. What do I need to do to get these parentheses by themselves to get rid of that 4 out in front? What do I need to do to get rid of the 4 that's out in front of my parentheses here? It's being times right now, so how am I going to make it go away? How do I make times cancel? With division. We're going to divide both sides by 4. So I get the measure of angle FEB is equal to, what's 80 divided by 4? 20. So it's 20 degrees. So how big is my other angle? This angle together with CEF, 70 degrees. Why? Because 20 plus 70 is 90 degrees. The other thing I could have done is substitute back in. Remember up here in the words where it said CEF is 10 more than 3 times FEB? What is 3 times this number? 60. What's 10 more than that? 70. I get the same answer either way. Number 2, last one, we're going to circle all of the things that we are allowed to assume, that can be assumed. Segments that look congruent, I'm allowed to assume are congruent. No, it has to be marked on there for me. I can't just assume that because they look the same size that they are. Vertical angles are congruent. Am I allowed to make that assumption? Yes. Formed by intersecting lines, no shared sides. Lines that appear to be perpendicular, lines that appear to cross in a right angle, I can just assume they are. No. Linear pairs are supplementary. What does supplementary mean? Adds up to 180. A linear pair has to have a shared side, and together it makes a line. If I put those 2 angles together, will they add up to 180 if they make a straight line? I am allowed to assume that. All right, warm-up page and homework need to go in the turn-in tray, and then I need your books open to page 85. Books open to page 85. Today we're going to talk about area and perimeter and circumference. What's perimeter? Anybody know what perimeter is? Outside, the distance around the outside. This is like how much fence I would need to fence in my backyard. I'm going to go all the way around the outside of a figure. Circumference is just a special word that we use for all the way around the outside of a circle. So it's still the same thing. The perimeter of a circle is the same thing as the circumference. Why they have 2 words for it is beyond me. I don't know. I didn't make it up. Perimeter we usually use for polygons, things that have straight sides. Maybe that's why we have a different word for it. So perimeter is the distance around the outside. Same thing with circumference. That just means I'm talking about a circle. What is area then? It's the inside space. So if the perimeter is how much fence I need to go around my yard, the area is how much grass fills in the inside of my yard. So the inside space. We have a couple formulas down on page 85 to talk about how to find perimeter and area for some common shapes. Ugh, I'm tripping over my words. First shape they talk about is a triangle. How many sides does a triangle have? 3 sides. I need to know how big each side is, and then I add them together to find the perimeter. To find the area of a triangle, I need one side. We're going to call that the base. And then I need to know how high it is to go all the way up to the highest point in that triangle from my base. When I'm talking about the height, it has to form a right angle with my base. When they measure you at the doctor's office, are you allowed to stand like this? You have to stand up straight against the wall. You have to make a right angle with the floor so that they can measure how tall you are. Same thing with my triangle. I need a right angle with the base to see how tall it actually is. Then we've got a square. Tell me about the sides of a square. They're 4 equal sides. So when I find the perimeter, I'm going to add one side plus itself, plus itself, plus itself, because it's 4 equal sides. So instead of doing s plus s plus s plus s, what's a faster way I could add up all 4 of those sides? S times 4, because I have 4 of the same thing. To find the area, we're doing length times width. S is my length and S is my width. When I take something times itself, that's squared, so S squared. I don't think I actually talked about the formula for our triangle for area. It's 1/2 times the base times the height. All right, 2 more shapes, and then we're going to actually get into a problem. Rectangles. Do rectangles have 4 equal sides? So what do they have? Has 2 pairs of equal sides. Top and bottom are the same. Left and right are the same. So when I'm finding the distance around the outside, I can add length plus width plus length again plus width again. Or I can say I've got 2 of these L's, so I'm going to do 2 times the length, because I have 2 sides that are the same, and 2 times the width, because I have 2 that are the same size there, and then add that together. So you can either add all the way around, or you can use this shortcut, 2 times the length plus 2 times the width. To find the area, length times the width. And then for a circle, we have some weird formulas for this. This has pi in it. Who's ever heard of pi before, other than the kind you eat? March 14th is my favorite day. It's Pi Day, 3.14. Circumference, distance around the outside of the circle, is 2 pi r. Does anybody know what that r stands for? Radius. What's the radius of a circle? Half. It's the distance from the very middle, the center, to the outside edge of the circle. So I'm measuring that distance from the very middle to the edge. So I do 2 times pi times my radius to find the distance around the outside. Or I can do pi times d. D is my diameter. What's the diameter? All the way across my circle, from one edge to the other, and it's got to go through the exact middle. So from one side to the other on my circle. That's 2 radiuses. Area for a circle, pi times my radius squared, pi r squared. When we do circumference and area for a circle in here, we're going to use the pi button on the calculator. We're not going to do times 3.14. These yellow calculators all have a pi button, and we're going to use those. We can use the distance formula. Do you guys remember using distance formula in the last chapter, last module? We had the big square root sign, x2 minus x1 squared plus y2 minus y1 squared. We can use that formula to find the lengths of sides of different shapes. We're going to practice doing that in just a moment. 2 more things real quick. If I say I have an equilateral shape, an equilateral polygon, that means all the sides are the same. So I can have a triangle with 3 sides that are all the same. What would I call a 4-sided shape where all 4 sides are the same? That'd be a square. It's a special kind of polygon. Polygon just means I have a shape with straight sides. Equiangular means that all the angles in my shape are the same size. Is that true about a square? Are all 4 angles the same size in a square? They're all 90 degrees. If I have a shape that all the sides are the same size and all the angles are the same size, I call it a regular polygon. If they say you have a regular polygon, I know right off the bat, all the sides are the same, all the angles are the same. All right, flip to page 86. With our last little bit of time, we're going to dig into this problem, and then we'll finish up on Monday. So I've got this shape over here. What shape are we looking at? A rectangle. And what are we supposed to find about this rectangle? The perimeter and the area. So we're going to find the perimeter and the area. How many sides on this rectangle are this big? What I just went over in orange. 2, that side, and this side over here. I'm going to call that my length. There's my L. Let's do this top one, because I know this one's the same size, so if I know how big this one is, then I know how big the other one is. What is that line segment called? What are the points that make up that line segment for that side? AD. So we're going to find the length or the distance from A to D. So I'm looking right here. I'm going to let -4 be my x1 and 2 be my y1. So 1 is going to be my x2 and 7 is going to be my y2. So we substitute that into distance formula, which they did for us already. So now we just need to simplify that. What happens when I do 1 minus -4? It becomes 1 plus 4. So I have 1 plus 4 squared plus, what's 7 minus 2? 5. So I have 5 squared. What's 1 plus 4? 5. 5 squared. So I have 25 plus another 25. What's 25 plus 25? 50. So underneath my square root sign, I have 50. Square root of 50. I do not want to put that in my calculator yet, because we're going to find the perimeter. I have to use that number in that calculation. And we're going to find the area. I'm going to use that number in that calculation too. We always want to stay with exact values until we get to the very end of our problem. So I'm going to leave it just like that. All right, so that gives me my length. We also have this side. How many sides do I have that are that size? 2. This one over here. I only need to find the length of one of them because the other one has the exact same length. What would this line segment be called? AB. So we're going to find the length of side AB. So AB equals, I'm going to leave my x1 and y1 the same, but for this, my x2 is now 0, and my y2 is -2. So once again, they were kind enough to substitute that in for us. So I have 0 minus -4. What would that be? 0 minus -4? Addition. So 0 plus 4, take it and square it. Plus, what's -2 minus another 2? -4. So I have -4 squared. What does it mean to square something? Times it by itself. If I take two negative numbers and I times them together, what type of number do I get back? Positive number. -4 squared then would be what? Positive 16. What's 0 plus 4? Squared? 16. What is 16 plus 16? 32. So I have the square root of 32. And again, I'm going to leave these in their exact form because I have to use them now in my calculations for perimeter and area. How many sides do I have that's this orange side, L? 2. How many sides for the blue side, W? 2. So if I want to find the perimeter, I need 2 times the length. What expression did we have for the length? Square root of 50. Don't forget that square root sign. Super important. Plus 2 times W. What do we have for W? Square root of 32. This is where you need those yellow calculators. Grab your yellow calculators. You're going to put in 2, and then second and this button right here to get the square root. Second, and then this button right here. It's next to the 7. That'll give you the square root. And then we're going to put in what? 50. Then you have to use this arrow key, or else it will keep putting things under the square root. And then you're going to do plus 2, second, and this button, and 32, and then hit enter. Tell me what the calculator screen reads just after you put that much in. 18 square root of 2. 18 square root of 2. Once you see that 18 square root of 2 on your screen, hit this back and forth arrow button right above the enter key and tell me what it is in decimal form. 25.45. I don't like your book. They rounded too small. I always want at least 2 decimal places. 18 square root of 2. This is my exact answer. That's the unrounded answer. Because it's 4, 5 what? 4, 5, 5. This would be my approximate answer. All right, we're just going to do some multiplication and then we're done. I want you to multiply the square root of 50 with the square root of 32, and then we're done. What is the square root of 50 times the square root of 32? 40. That one came out exact. This is why we do not round until we get to our final answers. If you rounded earlier in the problem, you would not get that exact answer that's nice and pretty and an exact 40. Homework that's due on Tuesday. It's only 6 problems because, as you saw, that one problem took us a while to work through. 1, 2, 3, 7, 9, and 12 due on Tuesday. I hope you guys have a fantastic weekend. Please stay hydrated. Stay in the shade if you can. And I will see you back here again on Monday.